An astounding revelation by the James Webb Space Telescope has captured the attention of specialists. Abnormal lights, evidently resembling cityscapes, have been discovered in space somewhere around 7 trillion miles from Earth. These shocking lights, transmitting from the exoplanet Proxima Centauri b, the closest known exoplanet to Earth, have ignited speculation about the possibility of life from other planets. Telescopes focusing on Proxima Centauri b revealed these extraordinary lights, raising concerns that they could indicate the presence of an extraterrestrial civilization. Join us as we explore how the James Webb Space Telescope identified these exceptional characteristics and what they could mean for how we might detect life beyond Earth. For a long time, scientists, along with the general public, have eagerly anticipated any sign of life outside our nearby planetary system. This new revelation has sent shockwaves through mainstream science. The James Webb Space Telescope, while studying the universe and sending crucial data back to Earth, discovered bizarre lights that appear to illuminate a city that is far away. Using Proxima Centauri b, the possible presence of an extraterrestrial city on this nearby exoplanet has baffled experts and laymen alike. It has also excited many, as it could provide long-sought proof of intelligent life. If these lights are indeed artificial, they could suggest that advanced, human-like civilizations in space are only just being recognized by humankind. As NASA engineers analyze these distant, city-like lights, they can't help but wonder how long they have been shining in space, waiting for humankind to develop the technology to detect them. David Kipping, a space expert from Columbia University, described Proxima Centauri b as an especially fascinating planet to study due to its unique thermal characteristics, which differ significantly from those of other rocky planets. Unlike typical planets that absorb light and emit infrared radiation, Proxima Centauri b exhibits an infrared signature distinct from its star, Proxima Centauri, making it an ideal target for the James Webb Space Telescope. The telescope's ability to detect infrared frequencies has made it the best tool for observing Proxima Centauri b's energy emissions and uncovering secrets about its atmosphere. Scientists are currently using the James Webb Space Telescope for further investigation of the mysteries surrounding Proxima Centauri b, analyzing its atmospheric components and potential for habitability. The telescope's infrared sensitivity allows it to study what happens on the planet's night side, detecting even the smallest amount of light emissions in the vast cosmic darkness. This capability is crucial for determining whether the city-like lights on Proxima Centauri b are indeed artificial. The telescope can detect any artificial light throughout the universe because it occurs at a predetermined frequency range, making the James Webb Space Telescope an invaluable tool in the search for extraterrestrial life. Proxima Centauri b has a unique relationship between its stellar properties and surface conditions. The exoplanet experiences regular day-night cycles similar to those on Earth, with its day side absorbing sunlight and its night side rapidly cooling. The temperature variations on Proxima Centauri b, influenced by its atmospheric structure, present an intriguing subject for further study. If the planet lacked an atmosphere, the temperature difference between day and night would be extreme, whereas a moderate atmosphere would reduce these fluctuations. The James Webb Space Telescope, with its unparalleled infrared imaging capabilities, is well suited to explore these thermal emissions and provide insights into the planet's atmospheric properties. Interestingly, the telescope's orbit around Earth aligns with Proxima Centauri b's orbital period, allowing for continuous observations of its day-night cycles, which last about 11.2 Earth days. If Proxima Centauri b indeed has an atmosphere, the next step will be to assess its chemical composition to determine if it could support life. Markers such as oxygen, water vapor, and methane would suggest that the planet possesses conditions that are habitable. Detecting these components requires careful analysis of light passing through the planet's atmosphere, a difficult undertaking even with a telescope as advanced as the James Webb Space Telescope. While the James Webb Space Telescope has limitations, especially in detecting free oxygen, an important indicator of life, it remains an essential tool for studying the atmospheric conditions of distant exoplanets. Scientists are also looking forward to the future of ground-based observatories, like the Extremely Large Telescope, ELT, which is set to begin operations in 2028. The ELT will provide additional insights into the atmospheric properties of distant exoplanets, complementing the discoveries made by the James Webb Space Telescope. Despite its current limitations, the James Webb Space Telescope continues to play a critical role in our quest to unravel the mysteries of distant worlds. Its ability to detect even the smallest hints of light from far-off planets allows for a clearer assessment of their atmospheres and potential for life. However, this work comes with challenges, as scientists must distinguish between gases produced by biological processes and those created by geological activity, like volcanic eruptions. The James Webb Space Telescope represents the cutting edge of scientific progress in the study of exoplanets. Its observations offer a glimpse into the complex revelations that await us as we push the boundaries of our understanding of the universe. As we delve deeper into space, the telescope will continue to provide vital data on distant worlds, helping us unravel the mysteries of these faraway planets. Many years ago, the space beyond our solar system was largely unknown. Since then, astronomers have identified over 4,000 exoplanets circling distant stars, proving the extent of human ingenuity. However, NASA sees these discoveries as just the tip of the iceberg, with trillions of exoplanets still awaiting investigation. Scientists are determined to explore these undiscovered regions in the hope of locating environments on other planets where humanity has never ventured. Over the years, there have been glimpses of hope in the search for extraterrestrial life. For instance, when the Galileo spacecraft visited Jupiter, its spectroscopic instrument detected an intriguing spectral signature, suggesting the presence of extraterrestrial vegetation, the first biosignature indicating life beyond Earth. This biosignature, known as the vegetation red edge, VIE, reflects light in a way that could reveal the presence of alien life. The James Webb Space Telescope, equipped with VIE detection capabilities, is expected to uncover environmental secrets from other planets by analyzing the orbital characteristics of potentially habitable planets within their stars' habitable zones. Once detected, the VIE could provide critical evidence in the search for intelligent life beyond Earth. As sunlight passes through a planet's atmosphere, the light is absorbed by molecules and atoms, creating a unique spectral pattern that can be analyzed through spectroscopy. This pattern serves as a fingerprint, allowing scientists to interpret the chemical composition of distant planets' atmospheres. It is believed that the James Webb Space Telescope could detect this light as it enters a planet's atmosphere. American space experts Jill Tarter and Thomas Pearson founded the Search for Extraterrestrial Intelligence (SETI) Institute in 1984. This non-profit organization focuses on studying the universe, particularly radio waves, which can travel vast distances without being dispersed or absorbed, making them easier to locate. The 42 radio telescopes that make up the Allen Telescope Array, located in California's Sierra Nevada mountains, have been monitoring these signals for over 30 years. However, despite their efforts, no convincing evidence of life from other planets has been discovered. Nonetheless, Jill Tarter remains hopeful, expressing confidence in the tools and the pace of 21st-century research. She encourages people everywhere to become actively involved in the ultimate search for cosmic companions. This mission continues, and recent reports from NASA suggest that the James Webb Space Telescope has detected SETI-like lights on a nearby planet. The telescope, humankind's most advanced instrument for exploring the universe, is currently in a 1 million-mile orbit around Earth, sending back data that scientists hope will determine whether intelligent life exists on other planets. Astronomers use spectrometers to analyze light emitted by exoplanets and their host stars, allowing them to gather crucial information about a planet's atmosphere and assess its potential for habitability. The James Webb Space Telescope can measure infrared light frequencies and identify gases essential for life, such as water vapor, oxygen, methane, and carbon dioxide. By analyzing the light patterns of these gases, scientists can gain valuable insights into a planet's ability to support life. While the James Webb Space Telescope has its limitations, particularly in detecting specific components like oxygen, it remains an invaluable tool for studying exoplanets and advancing our understanding of the universe. The telescope's ability to analyze light in the infrared range allows researchers to identify the chemical composition of a planet's atmosphere and determine whether it could support life. Although the search for extraterrestrial life continues to face challenges, the James Webb Space Telescope represents a significant step forward in our understanding of the universe and our place within it. As research continues to focus on the data sent back by the telescope, astronomers remain hopeful that they will one day find compelling evidence of life beyond Earth. The James Webb Space Telescope has made an extraordinary discovery that has amazed both scientists and the public. Unusual lights that resemble SETI lights have been detected on an exoplanet called Proxima Centauri b, which orbits the closest star to our solar system, located about 4.24 light-years from Earth. Proxima Centauri b has been the subject of intense study since its discovery, primarily because of its proximity and potential to harbor life. The lights, which seem to illuminate portions of the planet's surface, have sparked speculation that they could be artificial, perhaps the result of an advanced extraterrestrial civilization. The James Webb Space Telescope, with its incredible capacity to capture infrared light, has allowed researchers to examine Proxima Centauri b more closely than ever before. Before the telescope's advanced sensors, these extraordinary light patterns had gone unnoticed. During its survey of exoplanets within our galaxy, the James Webb Space Telescope has ignited excitement and interest among space researchers, who are now delving deeper into the data to understand the nature and origin of these lights. Proxima Centauri b orbits within the habitable zone of its star, meaning it could have the right conditions for liquid water, a critical element for life as we know it. This makes the discovery of potential artificial lighting even more intriguing, as it raises the possibility that life on this planet may have evolved sufficiently to produce large-scale artificial light similar to human cities on Earth. If these lights are indeed artificial, they could represent a civilization either contemporaneous with humanity or perhaps far more advanced. The discovery of these lights was made possible by the James Webb Space Telescope's sophisticated instruments, capable of detecting faint infrared emissions that other telescopes might miss. Infrared light emitted by warm objects can pass through dust clouds and reveal details that are often obscured in visible light. This ability allowed the James Webb Space Telescope to observe Proxima Centauri b's night side, the location where these lights were detected. However, it is not yet certain whether these lights are signs of an alien civilization or something more extraordinary. One of the key challenges in confirming their nature is distinguishing between natural and artificial sources. Natural explanations could include volcanic activity, bioluminescent life forms, or even reflections from the planet's surface features. However, the intensity, power, and consistency of the light patterns observed by the James Webb Space Telescope appear to differ from typical natural phenomena, leading researchers to consider an artificial origin. Given this discovery, space experts are conducting follow-up observations using both the James Webb Space Telescope and ground-based telescopes. These observations aim to acquire additional data about the light emissions, including their spectra, which could provide clues about their origin. By analyzing the spectra, scientists hope to determine whether the lights are produced by gases in the planet's atmosphere, surface materials, or artificial structures emitting light, similar to cities on Earth. The implications of discovering an extraterrestrial civilization on Proxima Centauri b would be profound, not only for our understanding of life in the universe but also for humanity's place within it. Such a find would challenge our assumptions about the rarity of intelligent life and could herald a new era of interstellar communication or exploration. However, researchers remain cautious, as extraordinary claims require extraordinary evidence. Much work remains before any definitive conclusions can be drawn. In the meantime, the James Webb Space Telescope continues to observe Proxima Centauri b alongside other exoplanets in nearby star systems, searching for additional signs of life. The telescope's ability to examine the atmospheres of distant worlds and detect signs of habitability makes it a key player in the ongoing quest for extraterrestrial life. Whether the lights on Proxima Centauri b turn out to be natural or artificial, their discovery has already rekindled interest in the search for life beyond Earth. It also highlights the potential of the James Webb Space Telescope to change our understanding of exoplanets. As the telescope continues its mission, it is expected to reveal even more about the universe, from the nature of distant worlds to the composition of exoplanetary atmospheres. Each new finding brings us closer to answering one of the most fundamental questions: are we alone, or is life a common occurrence in the vastness of space? For now, the lights on Proxima Centauri b remain a mystery, but they serve as a reminder of the possibilities that lie beyond our solar system. As technology advances and our observational capabilities improve, we may one day discover definitive evidence of life elsewhere in the universe. Until then, the question remains: the next steps in the search for extraterrestrial intelligence. As astronomers analyze the intriguing data from Proxima Centauri b, the scientific community is preparing for the next phase of research. In addition to continued observations using the James Webb Space Telescope, researchers are leveraging ground-based observatories, such as the Extremely Large Telescope, ELT, in Chile and the upcoming 30-meter telescope, TMT, in Hawaii, to provide even more detailed insights into exoplanetary atmospheres. These powerful telescopes will complement Webb's findings by capturing high-resolution images and spectral data that could help determine whether the mysterious lights on Proxima Centauri b are artificial or natural. Advanced spectroscopy will allow scientists to identify chemical signatures that may indicate the presence of technology, such as artificial illumination, industrial byproducts, or even controlled heat emissions. The implications of contact. If the lights on Proxima Centauri b are confirmed to be artificial, it would be one of the most groundbreaking discoveries in human history. The realization that intelligent extraterrestrial beings exist, and that they may have developed advanced technology, would force humanity to reconsider its place in the cosmos. Scientists and philosophers alike are debating the ethical and practical implications of such a discovery. Should we attempt to communicate? If so, How? What if these beings are more advanced than us? Could they pose a threat, or might they be allies in our quest to explore the universe? Organizations such as the SETI Institute and the Breakthrough Listen Initiative are already working on protocols for potential contact with extraterrestrial civilizations. Some researchers argue that we should proceed with caution, while others believe that an open line of communication could lead to extraordinary advancements in science and technology. The role of AI in the search for life. One of the most exciting developments in the search for extraterrestrial intelligence is the increasing role of artificial intelligence. Machine learning algorithms are now being used to analyze vast amounts of astronomical data, identifying patterns that human researchers might miss. AI-powered systems can quickly detect anomalies in planetary atmospheres, radio signals, and infrared emissions, helping astronomers focus their efforts on the most promising targets. AI is also being used to simulate how alien civilizations might develop, providing insights into what kinds of signals we should be looking for. These simulations take into account factors such as planetary conditions, energy consumption, and technological evolution, allowing scientists to refine their search parameters. Future missions and the next frontier. The discovery of potential artificial lights on Proxima Centauri b has sparked interest in launching more advanced space missions. Some experts are advocating for the development of interstellar probes capable of traveling to nearby exoplanets. Concepts such as Breakthrough Starshot, a project aiming to send ultra-fast, light-powered probes to Alpha Centauri, could one day provide direct visual confirmation of extraterrestrial structures. NASA, ESA, and private space companies are also exploring the possibility of sending autonomous spacecraft equipped with advanced sensors to scan exoplanets for signs of life. These missions would represent a major leap forward in humanity's ability to explore beyond our solar system. Are we on the brink of discovery? With each new technological advancement, humanity comes closer to answering the age-old question, are we alone in the universe? While the mysterious lights on Proxima Centauri b remain unexplained, they serve as a reminder that the cosmos is full of surprises. Whether or not these lights turn out to be evidence of an extraterrestrial civilization, the search for life beyond Earth continues to push the boundaries of human knowledge. The James Webb Space Telescope, along with future telescopes and space missions, will undoubtedly reveal more wonders in the years to come. For now, astronomers remain vigilant, scanning the skies for signals, studying exoplanets, and preparing for the possibility that one day, we may find undeniable proof that we are not alone.